Comets, welcome to class. This is Mrs. Brunk. We're going to be beginning day 3 of our exponent unit, and I'd like you to stop the video and try the warm-up questions 1 through 6. And by the way, question number 1 in the warm-up, that is actually supposed to say x squared raised to the 3rd power. Pause the recording now. Okay, so go ahead and check your answers on the warm-up. Okay, hopefully you've had time to go ahead and check your answers. And I want to just comment specifically on example 6. Example 6 asks you to raise a quotient, which is basically a division. So let's say you're asked to divide 3 to the 5th by 3 to the 3rd. One of your options is to expand out 3 to the 5th based on what you know about an exponent of 5, which says to multiply 3 by itself 5 times. And you could do the same thing with your 3 to the 3rd, and you'd have 3 3's on the bottom then, and 5 3's on the top, which then if you kind of go back to what we know about, cross-canceling, and how if you have something on the numerator that matches with something on the denominator, you can just simply cross those out. So you see that we were able then to cross out 3 3's on the top, and there are no more left on the bottom, which really means there's actually a 1 on the bottom. And so we see that all that's left is a 3 times 3 over 1, or 3 times 3, which really then can be written in exponential form as 3 squared. That's actually an example of the quotient of powers property. The quotient of powers property says this: the quotient, meaning when we're dividing, of two non-zero powers with the same base equals that base raised to the difference of the exponents. So notice when we look back at that example again, we had an exponent on the base of 3 of 5 on the top and of 3 on the bottom, and our final answer was 3 to the 2nd power, which is the difference between the 5 and the 3. So another numeric example of this property would be 6 to the 7th divided by 6 to the 4th, which is 6 to the 7 minus 4, or 6 to the 3rd power. This can also be applied when we're dealing with variables as well. So if we had something like a to the m power that we were dividing by that same base a raised to the n power, that would be the same as a to the m minus n power. Okay, so let's go ahead and flip the page. You should be on page 10 now of your guided note packet. And we're just going to, see if we can apply this quotient of powers property. We're going to try a few together. I'll have you pause the video and try some on your own. So we'll look at example A first. Example A asks you to divide 2 to the 7th by 2 to the 2nd, which would then give us 2 to the 7 minus 2 power. Just going to show you all the steps. You won't necessarily show that intermediate step, and that gives me 2 to the 5th power. Now 2 to the 5th power is a reasonably sized number. It's actually only 32. So in cases like that, we would expect you to go ahead and give the final numeric value. But you would want to be able to show the steps that you took to get there. So a minimum you should have 2 to the 5th and then equals 32. Now with variables, an example with our variables, x to the 4th divided by x to the 3rd. Because we know that what that really means is x times x times x times x, which is our 4 x's on the top, divided by x times x times x. Just to kind of show why this property works again, we can just cancel out 1 for 1, top and bottom, leaving us with just 1, x on the top. That's an x to the 1st. And we could have gotten that same thing by just subtracting. So I'd like you to pause the video and try example C and D independently. Okay, so let's check our answers for C and D. For C, our final answer should be 2 squared, which equals 4. And for D, now that was a little trickier because now we actually had no exponent listed in the numerator, and what that really means is that's y to the first. So this is really a y to the 1 minus 4 power, which is then just y to the negative third. And we know that it's not appropriate to leave negative exponents in our final answer, and so we're going to go ahead and use that negative exponent property to write this as 1 over y to the third. Okay, so now we're going to step up the difficulty level a little bit. Notice example E we've thrown in some variables, and we've got some other properties of exponents that we're going to have to use here. So my suggestion is really to kind of just see if you can first, if there's any simplifying to do in the numerator or in the denominator, to do that first before you look at the entire quotient. So what I would do is I would take a look at this denominator, which has a product that's being raised to a power, and remember that means that the 2 actually will apply to both the e and the d, so we could simplify that denominator to d squared times e squared. And then when you deal with variables like this, I think what the easiest thing to do is to, let me see if we change color, is to divide these up and look at the d's together and the e's together. So look at the common bases together, and that way, since those are the only things you can really put together is ones that have the same base, that makes it easier just to focus and just break it down into more doable parts. So looking at the d's, I have d to the fourth over d squared, which would leave me d squared. And then here I have e to the third divided by e squared, which would leave me with e to the first power. So that's our final answer there. And we can also do those same things when we are dealing with our numbers. If you want to just split them up and kind of just, and I even really will kind of just put those lines through. I mean, even myself, I still do this to help myself, to kind of focus on smaller parts. And take a look at the 3's. I have a 3 to the first, remember, over 3 squared. Now there's two ways to kind of look at that. You could look at that as just, 3 to the 1 minus 2 power, which is 3 to the negative 1. Or you could kind of go back to what you know about what this really means, that this really means 3 times 3, and you could go ahead and do some cross-canceling that way. I often find that's actually easier because it saves you a step at the end instead of having to go back through and take care of your negative exponents. But either way, we'll try this one this way, and then we'll maybe try another one together later where we do that method. When I look at the 4's, I have a 4 to the third and a 4 to the fourth on the bottom, so that would be a 4 to the 3 minus 4, which is also a negative exponent, a negative 1. And then I have a 5 to the fifth divided by 5 to the third. That's 5 squared. So to take care of the negative exponents, remember I have to take these guys here and move them to the bottom of a fraction, and that will change their sign of their exponent back to positive. And really, since it's just going to be an exponent of 1, you could just leave it off if you wanted to. And then finally, we're going to evaluate that. So 5 squared is 25. And 3 times 4 is 12, so that's 25/12ths for our final answer. And I'm going to go ahead and have you try the YTQs. I'm going to use that as a designator for you try questions. So I want you to go ahead and pause the video, take your time, just kind of see if you can reflect back on all the properties we've learned so far, and remember that it doesn't matter what order you do the exponent properties in, and see if you can go ahead and attempt G and H. Once you feel confident with your final answer, turn the video back on and check your work. So let's take a look at the you try questions. Notice with G, I tried to attempt this one a little differently in the way I actually mentioned earlier, where I, instead of actually literally subtracting the exponents, I really did more like a canceling strategy. When I went ahead and applied the power of a power property on the bottom, that left me with m to the fifth, n to the fourth, divided by m to the 10th times n, which is really n to the first. So then I went ahead and just did some canceling. I said, well, I'm going to cancel out this m to the fifth because there's more than 5 on the bottom. There's actually 10 of them on the bottom, so I canceled out 5 on the top with 5 on the bottom, leaving me with 5 m's remaining on the bottom. So what that allowed me to do is to kind of bypass that using a negative exponent and then turning around and having to rewrite it. And so that's a good strategy to use as well. It's maybe a little bit simpler, but whatever way works for you. And then the n to the fourth divided by the n, I could cancel out the n, which is really an n to the first, cancel out one of those and one of the 4 that were on the top, leaving me with n to the third, just 3 n's on the top. And I did a similar strategy for this one. So I ended up with 12/64, but don't forget, our most appropriate answers are always in simplified form, so you want to make sure that you've reduced your fraction completely. Okay, so we're going to be learning 3 different properties involving quotients today, the second of which is called the positive power of a quotient property. So this time, this is actually similar to power of a product property. The power of product property said if you have a product and it's being raised to a power, each piece of the product gets the exponent. Well, that same thing is being said here, except for now that we have a quotient. So it says that a quotient that is raised to a power, in this case positive power, we'll deal with the negative version later, equals the quotient of each base raised to that power. In other words, both the numerator and the denominator are going to get that exponent. So in this numeric example, we have 3/5 being raised to the 4th, and I know that whole thing is being raised to the 4th because the parentheses group the 3/5, that numerator and denominator together. So they're both going to get that power of 4, and you can see how they expanded that out. There's really 2 ways to look at that. You could look at that as saying 3/5 times 3/5 4 times, or you could look at it as saying I have 4 3's being multiplied on the top, and I have 4 5's being multiplied on the bottom. And a final answer then for that would be 3 to the 4th, which is 81, and 5 to the 4th, which I believe is 625. And that cannot be reduced. We can also use this property with variables. So when you see a situation where you have a quotient of 2 variables and that quotient is being raised to the power, just simply apply the exponent to both the numerator and the denominator. Okay, so this little note here really just kind of summarized what I just said about that last example, that really, you can think about a fraction being raised to a power in 2 different ways, as the entire fraction being multiplied by itself that many times, or simply as by separating the numerator and denominator. Here's an example of that. We have 4/7 that's being squared. I could think about that as 4/7 times 4/7, or I could think about it as 4 times 4 over 7 times 7, which when you multiply fractions, you multiply the numerators anyway. We multiply straight across and the denominator. So that's really the same thing. And this turns out to be 16/49. Okay, so let's take this property and we're going to apply it along with the other properties we've learned throughout the prior days, and we're going to get into some more elaborate simplifications. So let's take a look at a few together, and I'll have you try some independently. Example A. Let's take a look at that. So if we look, we have a quotient here of 3d squared over EF, and that entire quotient is being raised to the 4th power. So if we think about that in the context of this property we just learned, this 4 has to be applied to the numerator, which the numerator actually is a product. So we have to apply the 4 to both pieces of it, and then also to the denominator, which is also a product, and we have to apply it to both pieces of the denominator. So what this really means is 3 to the 4th power, and when we raise a power to a power like d squared and we raise it to the 4th, then we have to multiply the exponents. That's d to the 8th. On the denominator, both of those exponents on e and f are really just a 1, so when we raise the power to a power, it's just e to the 4th and f to the 4th. Now the first thing I do is I'll look to see, is there any common bases on numerator and denominator? Is there any way I can simplify there? And if not, then I just will make sure I don't have any negative exponents. If I have a numeric exponent like 3 to the 4th, I go ahead and evaluate that. 3 to the 4th is 81, d to the 8th, and the denominator is e to the 4th, f to the 4th. And that's our final answer. I'd like you to go ahead and try example B. Pause the video now and turn it back on to check your work. Okay, so your final answer for example B should be 4x cubed divided by y to the third. And remember that you're wanting to, if any of these are, you're having trouble with any of these, you try examples or really any of the ones that we do together. Please make sure you make note of it, whether you put maybe, say, a highlighted question mark in the margin and write a little note, ask a question, or maybe just so that when you get into class the next day, you're not forgetting, oh, that's right, I struggled with this one or that. You'll know exactly which questions you want to either ask your table mates about or to ask me about for further clarification. And I'd actually like you to go ahead and skip example C and D. So if you want to just go ahead and cross out those questions, don't cross them out, completely, because we might want to go back and use those for examples later on. But just cross out the letter for now, knowing that we're not going to complete them as part of our notes. And just go ahead and try example E as a you try example as well. So pause the video and check your work when you're done. So go ahead and check your work. Our final answer is a to the third over b to the third. Now I chose to do this using the that power of a power property first instead of using the quotient of powers. I could have also gone in here in the parentheses and done some simplifying by doing some canceling of the a's and b's within the parentheses and then apply the outside power of 3. I chose not to do that in this case, but it certainly would give you the same final answer. So the order of that you apply the exponent properties in is really up to you, whatever you're most comfortable with, whatever you see first. And sometimes the more comfortable you get with it, you'll see that, hey, this way might be a little easier, and just so you are aware, it really doesn't matter what order. Okay, we've reached our final property, and this one is the negative case of the property we just learned. So what about if we have a quotient that's being raised to a power that's a negative exponent? Okay, remember what a negative exponent really means. The negative is really a command. It says take the reciprocal of this base to the positive power. So when we think about a fraction, or in this case what we're calling a quotient, but a fraction is a quotient, when we think of reciprocal, we think flip it. In fact, we used to always call it refliprical. So one way that you can simplify something that has a negative power on a quotient is to just simply flip the fraction and then the exponent becomes positive. Okay, so if you notice in the numeric example, it states that, well, first of all, let's look at the property, what it says. It says a quotient raised to a negative power equals the reciprocal of the quotient raised to the positive power. So in their numeric example, they did just that. They started off with 2/3 being raised to the -4 power, and what they did is they flipped the they flipped the fraction and made it 3/2, which is the reciprocal of 2/3, and then the power became +4, and then they were able to apply the power in the same way that we did in the prior examples. So 3 to the 4th and 2 to the 4th. Our 3 to the 4th is 81. Our 2 to the 4th is 16, and I don't believe that can be reduced. As always, you can also apply this property to your algebraic examples with variables. So if you had something like this example, a over b raised to the -n power, simply flip your fraction, or take the reciprocal of it, and your power becomes positive, and then you can go ahead and apply the power of a quotient property to that. Let's try a few examples, and since the video is getting a little bit long, we're going to go ahead and I'm going to skip right to example B. So we may or may not come back to A at some point, maybe in class. So I'm just going to cross out A just to know we didn't do it in the video, and we're going to move on to B. So I've got 2x² over y cubed that's being raised to the -2 power. I'm going to go ahead and flip the quotient, take the reciprocal. And then now the power becomes a +2, and I can go ahead and apply that power to each part of the numerator and the denominator. So here I'm using the power of a power property. Y to the 3rd to the 2nd is y to the 6th. Down here I've got a product that's being raised to a power, so each piece gets the power, so that's 2 squared or 4. And x squared to the second, use the power of a power property. That's x to the 4th. And there's my final answer. Now the next example looks a little trickier just because you've got 2 different pieces of the expression that you have to simplify, but really it's no different than just doing 2 separate problems and then combining your final answer. So I'd like you to go ahead and pause the video, try this one independently, and then check back in for check your work. Okay, so let's wrap up this final you try example I'm going to have you do. My final answer turned out to be n cubed divided by 12m cubed. And so notice the steps along the way. We had to apply lots of different properties. We had over here, we had to do the flipping because we have a negative exponent, taking the reciprocal. We had to apply power of a power property and power of a quotient property along the way. And so after all of those properties have been applied, we end up with 72n to the third over 864m to the third power. Now I happen to know that was reducible because they're both even, but instead of having to kind of go through all of the possible factors of 72 and 864 to see how to reduce it, there's a shortcut. You can simply just put the 72 divided by 864 in your calculator. It will give you a decimal equivalent, but if you go to the math menu and you choose fraction and enter, it will then go ahead and reduce it for you. And I did that, and it reduced to 1/12. And that's it for today, except for one helpful hint, and this is something I see students do over and over again. This is a very common error that students make, and that's just to remember that when you're doing any canceling out, whenever all the factors in the numerator or the denominator divide out, you need to replace them with a 1. Because what we're really doing when we're canceling from numerator to denominator, we're actually dividing. And when you divide something by itself, you always end up with 1. So I hope things went well, and I'll be sure to complete the rest of your WISC, the S and the Q, your summary and your questions. Be sure to know any issues that you might have had during the presentation, and I'll see you in class.